أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum dear students. Please confirm that the screen is visible and the voice is clear.
Yes, sir.
Okay, thank you very much. Now I would request you that please kindly take a pen, paper and a calculator in your hand for today's class, because we are going to solve various numericals and problems related to the Terzaghi's and Merhoff bearing capacity equation. So we have, so we were focusing on the various factors related to Terzaghi's and Merhoff bearing capacity equations and theory in our previous lectures. But today we are going to use those theories, those equations, that how we can find out the ultimate bearing capacity, safe bearing capacity, and how we can find out the different types of bearing capacity factors. So today, in today's class, starting with noting down a few important equations related to your quizzes, assignments, and exams. So please kindly note down this equation, because we are going to use during the problem solving and numericals. So please kindly note down this equation. Also, please kindly note down the ultimate bearing capacity equation of the Terzaghi's. Please kindly note down the different shape factors for strip footing, rounded or circular footing, square footing, and rectangular footing. You can see that for rounded footing, we are having SC 1.3 and S gamma 0.6. For square footing, SC is 1.3 and S gamma is 0.8. Please kindly take a picture or a screenshot of this figure as well, which is the figure of Terzaghi's bearing capacity factors for various friction angles. We can find out NC, NQ, and N gamma, which are the bearing capacity factors. You can also take a screenshot or a picture of this table as well, which will give you the bearing capacity factors for Terzaghi's equation. Please kindly take a picture of this table as well, or a screenshot, because we are going to use this table in our today's lecture. Please kindly note down this equation in finding the height of the wedge and that will be used in today's lecture as well. Please kindly note down Meyerhof bearing capacity equation. Or take a picture of this equation, because we will be referring to this today. Please kindly note down these equations on a paper there with you, because we are going to find out the bearing capacity factors using the Meyerhof bearing capacity equation. Also, note down the different shape factors SC, SQ, and S gamma equations to find various shape factors. Then please also note down the depth factors and the Kp equation for finding the depth factors and lateral arc pressure coefficient in passive condition. Now, if you want to find out the inclination factors, we will need few equations. So please kindly note down this equation to find out the IC and IQ. In order to find out the I gamma, you can note down these equations to find different inclination factors. Yes, that's almost it. Okay, yeah, these are remaining. Please kindly note down these equations if you want to find out the eccentricity in the direction of width of the foundation or eccentricity in the direction of the length of the foundation. You can use these two equations, and if you want to find out the effective width of the foundation, you can use this equation. And if you want to find out the effective length of the foundation, so you can use this equation. Now, if you want to find out the effective area of the foundation, so you can use this equation. Once you have noted down these, okay, you can also note down these equations for finding the largest bearing pressure and the lowest bearing pressure. Okay. Now we will go and solve a problem on it. So for example, we are given with the strip footing and here we are given with the strip footing. The dead load is applied on top of that footing would be 500 kilonewton per meter, and the live load would be equal to 300 kilonewton per meter. The depth of the footing is equal to 0.7 meter. We need to find out the width of the footing. Water table is at the foundation level. C, or the cohesion, is equal to 0. Friction angle is equal to 40 degrees, and gamma saturated for this soil layer is equal to 20, and factor of safety should be equal to 3, and the unit weight for this soil would be 17 kilonewton per cubic meter. Now we need to find out the width of the foundation. Depth of the foundation is given. Loads, dead loads and live loads information is also given. Unit weight above the water table and the water table information is given. Shear strength parameters and the unit weight information and the factor of safety information is given. So please kindly start with this problem solution, and I need active participation in today's class, and the person or the students who are participating actively in today's class will be given extra preference in rechecking quizzes, assignments, or midterm and final term exams. And they will also get a few extra sessional marks if they miss by a few points, okay? So how we can start solving this problem? So what should be the step one? What should be the step one?
सर बेयरिंग कैपेसिटी फैक्टर्स फाइंड करेंगे.
Adil, can you hear me? Adil, please confirm, can you hear me?
Yes sir, अभी yes sir,
Adil.
अभी ठीक है, पहले नहीं ठीक थे सर.
Okay, thank you. So Ashad is saying that we need to find out the bearing capacity factors. So we will find out the bearing capacity factors, and the bearing capacity factors NC, NQ, and N gamma values. Now I need 3 readings for NC, NQ, and N gamma when we are given with phi equal to 40 degrees. 3 readings from the figure. Use the figure which I told you to take this screenshot or a snap of that figure which shows the bearing capacity factors.
सर 95.7
Now we need to
NC.
wait 95.7
NQ 81.3.
and N gamma
100.4.
Anyone else? I need 3 students to give me these readings.
सर एनसी यही आया और बाकी अभी कैलकुलेट नहीं की.
Sir,
Acha.
NQ is equal to 80.
NQ is 80, okay. Please kindly take calculator in your hand and do the necessary calculation, and please kindly give me the value for NC, NQ, and N gamma using the figure for Terzaghi's bearing capacity equation, from the Terzaghi's bearing capacity equation. So try with the figure, because usually the table won't be given in quizzes and assignments and exams as well. So usually figure is given during the exam. So I want you to try that how accurate you are going to get the values for the bearing capacity factors.
So n gamma equal to 99.
And gamma is 99. Okay. And how about NC?
Sir, 100.
Okay, let's take that 100. I need a third person to contribute as well in this class. So I guess one is Ashad and the other one is Sudes, if I'm not wrong. And I need a third person as well just to contribute. Anyone? Ejaz Ali, do you want to try?
Yes, yes, sir. Sir, n gamma
What's
is equal to 80,
okay? N gamma is 80,
nq is equal to 101,
101,
and nc is
NC,
equal to 98.
NC is 98. Okay, so these two values are more closer to each other. Yeah, this one as well. Okay, so a good agreement with the NC value, but a bit huge variation or deviation in NQ. So the values which I have, because C is equal to 0, so we don't need to worry about the NC value because that term, the first term will become equal to 0. The NQ value is 81.3 and the N gamma value is 100.4. Okay, that's, you need to note down this value and this value. Please kindly note down NQ and gamma. Now this is the step 1. Now what would be step 2? We got the bearing capacity
तो bearing
factors.
capacity find करेंगे ultimate bearing capacity.
Okay, ultimate bearing capacity की equation क्या है? तिरजागी की बताना.
सर मेयर होप की
तिरजागी की.
So QU is equal to CNC plus gamma NQ plus 0.5 gamma BNY BN gamma.
Okay, now this is equal to okay, now C is equal to 0, so this term will become equal to 0. Agreed?
yes
Now
sir.
the unit weight for the second term would be 17 and the D is equal to 0.7 and the NQ value is 81.3. Now we need to add the third term, and for the third term we need to use the gamma prime, which will be 20 minus 9.81, and that would be equal to 10.2. So the effective unit weight would be half of the gamma prime into B and into 100.4. Okay, solve for the B then. We need to find out the width of the foundation.
Sir, something around 1.88.
Something around 1.88. How? So that's how.
सर उसको हमने 17 इंटू 0.7 इंटू 81.3 को दूसरे साइड पे ले गए और फिर ये बी के साथ जो हमारे पास है इसको हमने वो कर दिया, उसे डिवाइड कर दिया.
Anyone else? सुदेश के पास जो है ना वो B हमारे पास आ रहा है कितना 1.88. ये एक है, चलिए B1 मैं कह देता हूँ. B2 क्या है, B3 क्या है?
सर मैं ये क्यों अल्टीमेट में कंफ्यूज हो कि इसकी वैल्यू क्या रखी?
अच्छा, कौन कंफ्यूज है? Who is the person who is confused?
आसिम सर.
Thank you very much, Asim. That is the valid confusion which should be there because we don't have the Q ultimate here.
यस सर.
So this we need to address first the Q ultimate issue which Asim is saying. Okay, so how we
Okay,
gonna
sir, yes, sir.
you understand that? Okay, now we know that Q, or we can write that factor of safety as the Q ultimate divided by Q applied. Now we can find out the Q ultimate and Q applied, where we know that factor of safety is this much, and how much is the Q implied? So that would be the load, and the load is dead load plus live load divided by the area. Now if we bring it here, okay, here, so we can write that 3 into 800 because 500 plus 300, and the area we can write B into 1 because it's strip footing. So we can take length of that footing is very great or greater than the width of the footing. Hence we can write Q ultimate so Asim confusion has been solved. Now you can use here in this equation this one. Can compare this equation with the Q ultimate, and that is 2400 divided by B. Now you can solve that for B, and I need 3 values for B. For example, we got 1.88 meter for the first width of the footing. So what would be the second value? Is it clear, Asim, now?
Yes, sir. Clear.
Please give me the B value.
Sir, 1.417.
Okay, 1.417. Name, please.
Yes, major.
Your name, please.
Adil, sir.
Adil is saying that
Adil Khan.
he got, yeah, Adil Khan is saying that we are getting 1.41. Initially, space was got the 1.88 meter. So I need a third person to confirm that should I go with this value or should I go with this value?
सर 1.94 मेरे पास आ रहा है दो वैल्यू प्लस 1.94 माइनस 1.94 तो
Okay.
1.94 यूज करेंगे.
Okay, that's a bit strange. I need a fourth value here as well. I need a fourth value here as well, please.
सर चैट में भी दो आंसर है.
चार्ट में ना देखिए, यहाँ पे सॉल्व करें. फोर्थ हमारे पास
वो कह रहा है कमेंट बॉक्स में सर मैसेज.
यार चैट में नहीं देखता हूँ यहाँ पे इस टाइम पे. सॉरी. ताहा रजा इज सेइंग 1.87 और 1.9. ठीक है, अगर आप मुझे बता सकते हैं फिर सुदेश आप उधर देखते जाएं. ठीक है, यहाँ पे हमारे पास है 1.89 और कितना था. एक्चुअली मेरे पास जो आ रही है वैल्यू वो 1.41 मीटर है. तो आई डोंट नो व्हाट मिस्टेक यू गाइस आर मेकिंग हियर. So please kindly redo the calculation and try. I guess Asim or Adil Khan got the right answer. Maybe that could be the right answer, but just check the calculation. But
Yes, sir. I also got the same answer, sir.
okay.
1.417.
Okay, thank you. That's great. So please confirm, Sudesh and others. Please kindly confirm Awais. Taha, confirm the calculations. We might be getting 1.417 meters. Okay, now we are going to move towards another problem, which is also a long retaining wall. So here we are given with the long retaining wall. The depth of that retaining wall is 1 meter, the width of this retaining wall is equal to 3 meters. Now, the problem says that the vertical load which is applied here is 282 kilonewton per meter, and the horizontal load which is applied would be equal to 102 kilonewton per meter. Now the resultant which is acting here, actually if we take the center of this retaining wall, so that eccentricity B will be equal to 0.36 meter. Now what else? C prime is equal to 0, and phi prime, which is the effective friction angle, that is equal to 35 degrees. Now the unit weight of the soil is equal to 18 kilonewton per cubic meter, and we need to find out the factor of safety. Okay, so we need to find out the factor of safety for this long retaining wall. Okay, having the depth of the footing, width of the footing is given, vertical load and horizontal load information is given, information about the eccentricity, shear strength parameters, and the unit weight is also given. Now, from where to start again? Step 1.
फर्स्ट सर क्यू अल्टीमेट फाइंड करेंगे, फिर क्यू अप्लाइड पर फाइंड करेंगे, फिर उससे वो फैक्टर शिफ्ट वाले फार्मूले से सर फिर एफओएस फाइंड करेंगे.
Excellent, but let's keep that order because this is a bit lengthier problem, so we need to go step by step. So first let's start with the eccentricities. Now give me the value of B prime, please.
.28 sir.
2.28 meter. Anyone else with the contradiction of the value? Or if they want to agree with the same value, they can say same 2.28, so I will continue.
2.28.
Okay, good. Now we need to find out the bearing capacity factor in the step number 2. Bearing capacity factors. So I need NC, NQ, and N gamma values using Meyerhof bearing capacity factors. Okay, use the Meyerhof bearing capacity equations. Use bearing capacity factors equations. Okay. I need 3 readings for NC, NQ, and N gamma. Please use Meyerhoff's bearing capacity factors equations. This is very important. Please remember these equations.
NQ 3.29.
Okay, please, Ashad, repeat again.
NQ is equal to 33.29.
Okay. We have 25 students right now, and luckily we will get more than 30 students after like an hour or at the end of the class. So you will see that suddenly we will see lots of students getting into the class.
Sir, NC is equal to 46.12.
Okay, 46.12. Okay, good.
Sir, NC is equal to 50.5.
50.5. Okay, so this is saying it's
NC is equal to 46.2.
46.2. Okay,
NQ is equal to 33.3.
33.3.
Sir,
And N gamma
N gamma is equal to 37.14.
37.14. Okay,
Sir, N gamma is equal to 37.2.
7.2. Waiting for this.
Sir, 33.29.
Okay, good. And gamma.
Sir, 37.17.
37.17. Okay. No issue here. No issue here. I would say slightly off here, but you are okay because this term will be equal to 0 because C is equal to 0. So if you are solving this problem, you would be okay with this. Okay, now we got the bearing capacity factors. What's the Kp value? And Kp we can find out and that would be equal to
3.69.
3.69. Thank you. Now, how about the shape factors? So it's kind of a strip footing because it's a long retaining wall. So for long retaining wall, we already know that SC is equal to SQ is equal to S gamma. That would be equal to 1. Agree here. Now we will Need to find out the depth factors as well. What should be the DC, DQ, and D gamma values? DC, DQ, and D gamma values.
So DC is equal to 1.16.
Sir, DC 1.16 TK.
Okay, that's good.
Sir, DQ is equal to 1.08.
Okay.
और सर DR भी DQ के बराबर है.
Okay.
Sir, DC is equal to 1.17.
DC. Okay, DC is 1.17.
17.
Okay, it's almost same. That's fine. How about the DQ? Please confirm that.
1.08.
1.08. Okay, so we got, please note down these values as well. Now we are going to find out the inclination factors. Inclination factors. Now, in order to find out the inclination factors, we are going to use the theta equation. And we will get the theta value, which is the inclination with the vertical load. Then we need to find out IC, I tune, and I gamma. So what is here?
22.09 सर ये थीटा आता है
20.
22.09
Okay, 22.09. Please confirm.
Sir, 19.9.
19.9. I need a third value. Okay, it's almost same, so I would assume that these values are okay. Please.
IC is equal to 0.569.
0.569. Okay.
IQ भी same है.
IQB 0.569. And how about the I gamma?
Zero, sir.
This is 0.
Sir, IC equal to 0.57.
Okay. And IQ?
Same ही होगा sir.
I gamma?
सर IC और IQ बराबर है 0.61 और I gamma बराबर है 0.1.
Okay. I gamma here. I guess so this I gamma is missing here.
Sir, 0.24.
0.24. Okay. I would go with these values. Seems that my values are much closer to the third values. Now we got the NC, the bearing capacity factors, we got the shape factors, we got the depth factors, we got the inclination factors. Now we can use the Meyerhof bearing capacity equation and use the lengthy equation of the Meyerhof, and I need Q ultimate. Use all these bearing capacity factors, shape factors, depth factors, inclination factors, and I need the ultimate bearing capacity of that soil. Okay, and then you can find out the P ultimate and then you can find out the factor of safety.
सर बियरिंग कैपेसिटी की वैल्यूज थोड़ा दिखा रहे सर, वो मैं नोट नहीं की थी.
Okay, bearing capacity factors. You want bearing capacity factors values. So I would say pick these one, or even the lower one as well. Bearing capacity factors, shape factors,
So I'm
depth.
getting 7.21.
Okay, 7.21. Let's go with the blackish one this time. 7.21. Okay, that would be in kilopascal. Okay, 7.21. So we got the first ultimate bearing capacity of that soil. using all those bearing capacity factors, shape factors, depth factors, and inclination factors, we came up with 7.21 kilopascal of the bearing capacity of that soil. I need two readings for the ultimate, Q ultimate, and now Ashad, you can go for the T ultimate and the factor of safety as well.
Okay, sir.
Okay, so you can solve the other part of this problem. Q ultimate. बाकी स्टूडेंट्स को समझ आ रही है? आसिम,
सर 1
आदिल,
मिनट।
यस सर आ रही, लेकिन वो वैल्यूज हमने नोट नहीं किए इसलिए।
अच्छा चलें मैं आपको बता देता हूँ, फिर नोट डाउन कर लें। ये हमारे पास वैल्यूज हैं NC की जो 46.12, NQ 33.29 एंड गैमा 37.14। फिर हमारे पास शेप फैक्टर्स हैं। शेप फैक्टर्स फॉर स्ट्रिप फुटिंग हमारे पास सेम होते हैं, 1 है, और वो हमने कहाँ से लिए? वो हमने यहाँ से लिए। अगर आपको याद हो कि हम पहले क्लास के स्टार्ट में हमने आपको बताया कि आपने करना यहाँ से इन, और जो जो इक्वेशंस, टेबल्स, फिगर्स मैंने बताई हैं कि आपने काइंडली इसको नोट डाउन करने या स्क्रीनशॉट लेना, ये इंपॉर्टेंट है। ये आपके क्विज असाइनमेंट और एग्जाम में बहुत काम आएंगी। तो यहाँ से हम स्ट्रिप फुटिंग की वो ले रहे हैं, यहाँ पे भी है, और अगर हम मेयर-हॉफ इक्वेशन इस्तेमाल करना चाहते हैं तो यहाँ पे भी हमारे पास शेप फैक्टर्स मौजूद है। ठीक है, यहाँ से भी SQ, S गैमा और SC हम निकाल सकते हैं। अच्छा, फिर हम आते हैं यहाँ पे, शेप फैक्टर्स हमारे हो गए थे। डेप्थ फैक्टर्स 1.16, 1.08 और 1.08 आप DQB और D गैमा भी ले सकते हैं। IC, IQ, I गैमा, IC, IQ और गैमा के लिए 0.61, 0.61 और 0.18 आप ले सकते हैं। हाँ, अल्टीमेट जो है ना वो बियरिंग कैपेसिटी, अगर आपके पास सारे फैक्टर्स आ जाते हैं, once you simply add and multiply the first, second and third term, and then you will come up with a value which will give you an ultimate bearing capacity of that soil using Meyerhoff's bearing capacity equation or Meyerhoff bearing capacity theory. I hope it's clear now. Give me those two readings so that we can continue with the P ultimate or the load which is applied. Q ultimate is basically the pressure or the stress which is applied onto the soil, and the soil can take how much that load can be taken by the soil, and how much load can be taken by the soil would be the P ultimate, and the Hent would be stress divided by the area. And in this case, the area is width of the foundation, because you can take length of the foundation as 1 because it's a long retaining wall. And then you can find out the factor of safety, and that what is desired.
Sir, P ultimate 2.4.
Okay, so we are getting 2.4 now. Oh, sorry.
Sir, P ultimate.
Okay, I got it. Yeah. This would be 2.4. I would say kilo Newton per meter, and this would be in kPa. So there's Adil Khan, Asim.
Sir, Q ultimate is equal to 543 kV.
543 kilopascal. Good. Okay. What else? How about the P ultimate? Ashad, please confirm because we are getting a huge difference.
Okay, sir. Let me confirm.
Sir, Q ultimate is 550.24 and P ultimate 1254.
Okay, please one by one.
50.
550, and how about the P ultimate?
1254.
1254. Okay, thank you. And you can go and find out the factor of safety as well. So there's waiting for the P ultimate.
सर ये इन गेमा की वैल्यू दिखा दें, ये शायद मैंने गलत लिखी।
Okay, let's go for the N gamma. 37.14.
Okay, sir. Thank you.
बाकी सब स्टूडेंट्स को समझ आ रही है? इसफंदियार, आतिफ, आयशा, असद मीर, इजाज अली, इश्तियाक अहमद, आगा शाहिद, रफीक, ताहा रजा, उमर जलाल, उस्मान खान, वकास अहमद, मोहम्मद जैद, निहारुल्लाह, अवैस जफर, तौसीफ जुनैद खान, ज़ैनब अकबर। सबको समझ आ रही है?
Yes,
Sir,
sir.
P ultimate is equal to 1238.
ओके। सो हमारे पास ये P अल्टीमेट कितना आ रहा है?
1238.
1238 किलो न्यूटन पर मीटर। ठीक है। फैक्टर ऑफ सेफ्टी, फैक्टर ऑफ सेफ्टी को आप फाइंड कर सकते हैं P अल्टीमेट डिवाइड बाय P अप्लाइड, और P अल्टीमेट हमारे पास, फॉर एग्जांपल मैं आपको ये बता देता हूँ कि यहाँ पे मेरे पास जो रीडिंग आ रही है वो 563 किलो पास्कल है। थोड़ी बहुत डिफरेंस इसमें भी हो सकती है, मुझसे भी गलती हो सकती है, लेकिन यहाँ पे हमारे पास जो रीडिंग आ रही है वो 1283 है। तो बेस्ड अपॉन 1283 और जो अप्लाइड लोड है वो हमारे पास 282 है, 282. ओके, हमारे पास फैक्टर ऑफ सेफ्टी कितनी आ रही है? 4.5, and that what was desired or required in this problem. फिर हमारे पास एक दूसरा प्रॉब्लम आता है, और उस प्रॉब्लम में बेसिकली एक्सेंट्रिसिटीज के बारे में जो कंसेप्ट हमने डिस्कस किया था प्रीवियस लेक्चर में, उसको डिस्कस किया जाएगा और उसको एक्सप्लेन किया जाएगा। बी हमारे पास क्या है? 1.8 मीटर है। एल हमारे पास 1.8 मीटर है। ठीक है, जो कॉलम की डायमेंशन है वो हमारे पास 0.4 मीटर और 0.4 मीटर है। अगर इस पे हम ड्रा करें, ये टॉप व्यू है, ये हमारे पास एक्स एक्सिस हो जाएगा, ये हमारे पास वाई एक्सिस हो जाएगा। यहाँ पे कहते हैं कि मोमेंट्स अप्लाई हो रहे हैं, और वो मोमेंट्स जो अप्लाई हो रहे हैं उसके लिए हमारे पास ई बी जो एक्सेंट्रिसिटी है वो 0.2 है, और मोमेंट्स इन द डायरेक्शन ऑफ विड्थ ऑफ द फाउंडेशन वो हमारे पास 360 किलो न्यूटन मीटर है। ठीक है, फिर हमारे पास जो एक्सेंट्रिसिटी, ये हमारे पास ले सकते हैं कि ई बी है, और ये हमारे पास यहाँ पे ले आते हैं कि ई एल हमारे पास कितना हो जाएगा? 0.25 मीटर, और एम एल जो कि मोमेंट्स हैं इन द डायरेक्शन ऑफ द लेंथ ऑफ द फाउंडेशन 450 किलो न्यूटन मीटर। ठीक हो गया। फिर हमारे पास इसके अलावा आता है कि ये हमारे पास इफेक्टिव फाउंडेशन हो जाएगी या इफेक्टिव एरिया हो जाएगा ये वाला, तो इसको हम एल प्राइम कह देंगे और इसको हम बी प्राइम कहेंगे। नाउ वी विल कॉल this distance 2e x, and that would be equal to 0.4 meter. Similarly, we would call this distance as ey, or 2ey, sorry. So we can call that as 2ey and 0.4 meter as well. And that would be, sorry, 0.5 meter. Okay. What else we are missing? We need to find out Q allowable and we also need to plot the cross-sectional view of the foundation and in the cross-sectional view is shown that the vertical load V is equal to 1800 kilonewton and the moment which is applied onto this foundation in the direction of the width of the foundation will be 360 kilonewton meter. Here the width of the column is 0.4 meter. The depth of the foundation is equal to 1.8 meter, and the depth here I would say here is the water table, and that is 6.1 meter. What else? Friction angle is equal to 36 degree for the soil, and C equal to the cohesion is 220 kilopascal. The unit weight you can use 18 kilonewton per cubic meter. So you can take a picture of, or you can take a screenshot of this problem or the plan or the top view, and the cross-sectional view you can also take the screenshot, because we are going to solve this problem. You need this information. Again, eccentricities are given, moments are given, length and width of the foundation is given, the effective length and effective width of the foundation is also given. Now the vertical load, depth of the footing, and shear strength parameters, unit weight information, and the location of the water table is also given. So from where to start? From where to start? Now water table information is given, so we need to check that whether the, okay, please confirm that you can hear me and the voice is clear and the screen is visible.
Yes, sir.
Okay, thank you. Now we need to use this equation. Okay. And what would be the value? Please give me the value for the edge, height of the wedge.
1.25.
1.25.
सर सेम आ रही है.
Okay, let me confirm. This is the equation which we are going to use to find out this effect, okay? Then we are going to compare it. I don't know why I am.
1.76.
Yeah, okay. Thank you very much. I thought maybe
Sir,
there is an error.
1.76.
I thought maybe I'm having an error here. So it's 1.76, which is less than the depth of the water table. So no effect of the water table. Okay, so we will ignore the effect of water table. If it was greater than the depth of the water table, then we are going to use the effective unit weights for that third portion. Now we will find out the eccentricities. Then I would say step number 2, so give me the values for the EB, give me the values for EL, and I need values for B prime, and I need value for L prime. What else? Yes, yeah, that would be good. Statement 2. Okay, those would be for the eccentricities. Now we need to find out the bearing capacity factors as well, and we need to use the Meyerhoff's bearing capacity factors, and we need
Sir,
to find out
B prime 1.4.
1.4 meter and Q and N gamma. Okay, and the friction angle is equal to 36 degrees.
L prime 1.55.
1.5 L prime.
Sir, EB is equal to 0.2.
Okay, sorry.
EB is equal to 0.2.
EB, okay, EB is equal to 0.2,
EL is equal to 0.25.
0.25,
ये L prime 1.3 है मेरे साथ.
L prime is 1.3, okay, so we are getting, what I'm getting here is 1.4 and L prime is equal to 1.3. Now we need to swap these values because B is the width of the foundation. So B prime will be equal to 1.3 and L prime would be equal to 1.4. Is it clear, Ashad? So this Adil.
Yes, sir.
Okay, so you need to swap these values. Once you get the B prime and L prime, if the B prime is greater, then you need to change these values to B prime and L prime correspondingly or respectively with the.
रिपीट कर ले सर.
ओके, अगर हमारे पास ये देखें B प्राइम 1.4 आ रहा है, L प्राइम 1.3 आ रहा है. अब जो सबसे छोटी वैल्यू है उसको हम B प्राइम कंसिडर करेंगे, इसको हम B प्राइम लेंगे और L प्राइम को जो है ना हम 1.4 लेंगे. अगर हमारे पास बी प्राइम इन केस जो है ना छोटा आ जाए, छोटी वैल्यू आ जाती है, अगर बी प्राइम हमारे पास लेट सपोज 1.3 आ जाती तो फिर बी प्राइम 1.3 ही रहता। अगर हमारे पास एल प्राइम जो है ना 1.4 आता तो वो बड़ी वैल्यू है, क्योंकि लेंथ जो है ना वो ज्यादा होती है और जो विड्थ है वो कम होती है, तो इस लिहाज से उसको हम स्वैप करते हैं या इंटरचेंज करते हैं। ठीक है, आइए समझ सुदेश।
Yes, sir. Thank you, sir.
Okay, welcome. No worries.
Sir.
Now, okay, please.
सर एल प्राइम हमारे पास एल माइनस ई एल के बराबर होता है।
2EL, ये करेक्शन मैंने आपको बताई थी कि 2EL, L माइनस 2EL। ओके, वीडियोस में भी चेक करें, उसको देखें, मैंने उसमें करेक्शन की हुई है, वो हो सकता है कि टाइपो है।
बिल्कुल, यस।
ओके, अभी अगर हमारे पास फी जो है ना 36 डिग्रीज हो, तो एन सी एन क्यू और एन गैमा को हमने फाइंड करना है, तो हम कैसे फाइंड करेंगे और उसकी वैल्यूज क्या होगी? I need NC, NQ and N gamma values using Meyerhoff's
Sir,
bearing
n
capacity
क्यू
equation. Okay, please.
n क्यू 37.75.
N gamma, NC.
NC सर हमारे साथ 50.5।
50.5 सबर करें, NC 50.5। N
एन
gamma
गेमा
हमारे
is 44.4.
44.4, it's okay. And C is 50.5, NQ is 37.75. Okay, that's good. Now we need to find out the shape factors as well. SC, SQ, and S gamma. And how we can find out, if anyone is still confused, you need to remember these bearing capacity factors equations, you need to remember the shape factors, and you need to remember the depth factors and the inclination factors. Okay, still if anyone is confused, these are the equations, and it is a very important slide from quiz assignment and exam point of view. SCSQ and SCAM.
सर ये SC हमारे साथ 1.715।
Point.
1.715.
Okay, good. What is SQ?
1.357.
1.357. S gamma.
इस गेम में भी
1.357. Agree? Now, how about the depth factors?
सर ये शेप फैक्टर्स पे जाए सर ये पे
Any problem, any issue with the shape factors?
नो सर अपने वैल्यू चेक करा तो उसके सही है सर
Okay. How about the depth factors? DC, DQ, and D gamma.
सर DC is equal to 1.54.
And DQ and D gamma.
सर दोनों की एक ही वैल्यू है 1.27.
Okay, now we will find out the inclination factors.
Excuse me, sir.
Yes, please.
सर थीटा यहाँ पे 0 होगा
Yes.
सर तो तीनों की एक ही वैल्यू is equal to
1 आ जाएगा
So we don't have any horizontal load applied there, and only vertical load and moments are applied. So that's why the inclination factors will be equal to 1. Now we will use find out the ultimate bearing capacity using Meyerhof bearing capacity equation.
सर ये वैल्यूज रिव्यू कर दें सर एक बार।
Okay. NC 50.5 and Q and gamma 44.4. Then SC, SQ, and schema values. Here, these are the shape factors. Then these are the values for the depth factors. Inclination factors. Now we need to find out the Meyerhof bearing capacity. We use the Meyerhof bearing capacity equation and we will find out the bearing capacity.
Sir, K ultimate to 5651.5 kilopascal.
5651
51.5.
kilopascal. Okay, we will leave that 0.5 for the time being. So there's Ashad Q ultimate using Meyerhof bearing capacity equation. Please.
Okay, sir. 2 minutes.
Sir, 5483.
5483.
Sir, 5376.
5376. Okay, let me see what I got. 5688 kilopascal. Okay, now what would be the Q safe? Then it will be Q ultimate divided by the factor of safety. And we will come up with the Q safe equal to 1896 kilopascal. So that's how we basically, the main idea or the main concept or the main theme of today's lecture was to find out the bearing capacity factors, that how we can find out the different factors which are used in Tezagi's bearing capacity theory, and also various factors which are used in the Meyerhof bearing capacity theory. So we find out that we need to find out first of all the eccentricity if we are given with the moments, and we also need to find out the height of the wedge, that whether the height of the wedge lies beyond the water table depth or above the water table depth, so that we can take into consideration the effect of the water table there as well. More fundamental factors, for example, the bearing capacity factors, depth factors, or the inclination factors, we can find out those factors and we can use them in the Meyerhof bearing capacity equation. Thank you very much for listening very patiently. I guess we need to stop here for the today's lecture.
सर
Please.
सर ये फैक्टर आप शिफ्ट यहाँ पे क्या लिया हुआ है?
I guess it's 3. Yeah.
Okay.
Yeah, it's 3. Now you can write down your student